In this video, I'll give a quick overview of how to use a z-table. So the first thing that I want to make clear is sometimes we have a z-score and we want to look up a probability. And other times we have a probability and we want to look up a z-score. And so our strategies are going to be different depending on what our goal is. So whether it's the first option or the second option. So let's discuss this first option where we have a z-score and we want to find the probability. Let's say that we have a z-score of negative 1.96. You'll want to notice that certain different z-tables are set up differently. Most of them will have some sort of indication of their layout with a graphic. So look at the top or somewhere on your table and see, look for a bell-shaped curve, and oftentimes there will be a picture where they have a certain region shaded, and this is showing you how the z-table is set up. So if you see something like this, it means that when you look up a z-score, you're actually getting the cumulative distribution, so the probability that's to the left, or the area that's under the curve to the left of this marker. So I have a z-table here. Let's see if I can get that to focus a little bit better. One more time. Okay, that's looking pretty good. So notice that this is set up so that we're going to, if we have a z-score, we can look up the area that's to the left. That's fine. If we want the area to the right, we can always subtract from 1. So the z-score that I'm interested in is negative 1.96. So when I look along the left-hand side here, I see z-scores at least to the 10th space. So there's one decimal place. So I'm looking for negative 1.96. So I can at least find the negative 1.9 here. So to find accuracy to the 100th place, I'll use the column marker. So here's 0.06. So when I come down to negative 1.96, that's the intersection of those two, I find a probability of 0.0250. So the values inside the table are areas to the left of the z-score, and the z-scores are actually, the column headers and the row headers. Now, if I want to go in the other direction, let's say that I have a probability. So here we found that this z-score corresponds to the probability or area of 0.0250 in the left tail. If I want to look up a probability to find the z-score, let's say that we have a probability of 0.05. That would correspond to 5%, and again this would be 5% in the left tail. Since I have a probability and I want to find the corresponding z-score, I'm looking inside the table. Here's where my probabilities are. So I want to find the value as close as possible to 0.05. So let's see. They're going to get larger as I read across here. So at this point I see two values that are very close to the one I want. Here's 0.0505 and here is 0.0495. So this is in the column of negative 1.6. So I'm going to make a note here that's z equals negative 1.6. And as far as the 0.0505 and 0.0495, those the value that I want is actually right in the middle of those two. So let's see what the two column headers are. If I look up from the 0.0505, I find a 4 in the 100th place. So that would be this. So that corresponds to this guy. And negative 1.65 corresponds to this guy. So I want to find what's right in the middle. So that would be my 0.05. So I'll just average these two values. So if you add negative 1.64 and negative 1.65 and divide by 2, you'll find that halfway in between is negative 1.645. So that's the z-score that I want. Now, this table only has it has, it's only on one page, and it goes from negative 3.4 all the way up to positive 3.4. And let me just move this so that you can see. There's positive 3.4, and it goes to a column of 0.09. So I can go from negative 3.49 up to positive 3.49. Now, in some tables, you'll find that this is split between two different pages. So there'll be a page 1 where you have your negative z-scores, and a second page where you have the positive z-scores. Now, notice that when I go from negative 3.49, which is in the top right, the probabilities get larger, and here at what will correspond to 0, so negative 0.0 or positive 0.0, notice that we see that's the 50% mark. That makes sense because 0 is the center of this distribution, and to the left of 0 is half of our area, and to the right is half the area. So if I just look at the cumulative probability, of course that is 50%, and this is 50%. So if you're looking for a probability above 50%, you'll want to look at the part of the table where you have z-scores that are positive. And let me just give one more example. Let's say that we want to find the z-score that corresponds to a probability or area under the curve of 0.95. And I want to know the z-score that is the cutoff so that 95% is to the left, or there's an area of 0.95 to the left of this marker. So now I'll look in my table and try to find 0.95. Let's see if we can get this to focus again. Yeah, that's looking better. So 0.95. Notice again there's a 0.905, a 0.945. So in the table I find 0.9. Let me see that again. 0.9495 and 0.9505. And these are in the column of positive 1.6. So over here I see plus 1.6, and those are in the columns. So let me just mark this off again. 0.9495. Those are in the columns with 0.04 and 0.05. So 0.04 and 0.05. Once again, this, if I take, here's where the values, this is the row, and these are the columns where I'm finding these two values. So this corresponds to 1.64 and 1.65, and I'll take the average of those and so add them together and divide by 2, and I get positive 1.645. So notice that the z-score here that separates the top 5% is just the opposite of the z-score that isolated the bottom 5%. So before we found negative 1.645 and positive 1.645. We can use the fact that this distribution is symmetric and centered at 0. So if we find the z-score that separates the bottom 5, we can just take its opposite, and that'll be the z-score that separates the bottom 95 from the top 5. All right, I hope that helps.